Ethan and I are in our quality control lab, and if you just do kind of a quick pan, you can see there's a lot of things that are going on. These are compartments where we're storing our cylinders, our concrete cylinders, and once the cylinder is hardened, we're going to take that and we're going to break that cylinder, see what kind of strength we get. One of the important parts of making a cylinder is that you have consistent concrete consolidation in the cylinder, so you get consistent measurements. If you don't do that, it's not going to be consistent. So Ethan, tell us about what these tables down here are used for.
So these are our shaker tables. They allow them to compact and get the concrete to be the right consistency before it actually dries.
Can I turn it on? Okay, so you can feel that it's vibrating, right? So we set the cylinder, it'd be one of these guys.
Yep.
We don't have our QC techs here, but there'd be a cylinder, and they would pour some concrete in. They're going to use one of these tampers, right? They're going to kind of boom, 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 tamp that down. And then they're going to flip this thing, flip that on, and we're going to end up with the cylinder. Mm-hmm. Now, one of the things that I'm noticing, and this is why I think it's so important that you're here, this is a lot of work. You're down low. You're bending over. These things are really heavy. This thing's heavy. Yep. So tell us what your plan is and what you've been responsible for.
I made a table. I fabricated it myself, welded it up, and it's going to be, I think it's 24 inches tall. Brings this table up to about waist height.
Nice.
And then it's a lot easier for them to pick up, and then they have to put it in that machine.
Yeah, eventually it goes in the compression machine.
So it makes it very easy to just pick it up,
move it over there, drop it in the machine, and away we go.
And we're looking into an even better way to do it, where it actually lifts it up for you, so you don't even have to pick one of these up off the ground. It'll just lift it up, put it on the table.
So this will be now, instead of me being down here, I'm going to be here.
Yeah.
Right. So you raised it, maybe 8 inches or so?
It's 22 inches tall, I believe.
Okay.
So once you put the shaker table on, that's another 8 inches on top of this. It's perfectly waist height.
So the shaker table that we were just looking at is going to rest right on top.
Yes. Yep.
I got you. Okay. I wonder if the vibration frequency is going to change from being on the ground to being up on this table at all.
If anything, it should get better, because this is over 100 pounds and it's going to be bolted down to it. So it's actually going to make sure that the table only shakes what's on top and not the entire shaker itself.
Very cool. So Nicholas and I are standing in our wood shop, right?
Yep.
And Nicholas has a project he's working on, which is?
I'm working on a foam cutter. Currently we are using a bandsaw to cut our foam, and it's creating a decent amount of debris and a lot of cleanup. So we're looking at alternative routes to cutting the foam.
Okay. We're using this foam. This is what we're sandwiching our concrete wall panels around.
Yep.
So that when our customers go to heat their building or cool their building, this guy's making sure it doesn't lose that temperature. And so what you're saying is we cut these down to fit into a certain panel size.
Correct. So currently we're taking a foam piece and pushing it through a bandsaw.
So what is it that we're trying to improve on?
So right now we're trying to reduce all the pretty much debris coming out from the cutting.
Okay.
Because what happens is a lot of the small particles go into the air and we're breathing that in.
Okay. So I'm going to plug this in.
Yep.
Is that okay?
You're good to go.
Oh,
right now we're going to turn it all the way down so you don't have to worry about that.
Okay.
For demonstration, we're just going to set it down there. So what happens is we give this wire pretty much a constant voltage. We can go the full 8 feet, but for our demonstration, we're just going to do a shorter length.
Yeah, there you go. That's where the wire is. And it's not on at the moment.
Nope.
Okay.
Nope, so this one you can actually touch. It's not going to do anything.
Okay.
So to cut foam, we have to get about a temperature of around 450. That's our goal. And for the 8-foot length, this power supply will actually bring it up to that temperature.
Okay.
Of course, the shorter length, you can power it more and get a hotter. The hotter it is, the faster it cuts. But when you get too hot, it creates a fume that is more toxic. So you don't want to actually make it too hot.
Too hot.
You want to find that perfect in between. So we spent about a week working on the perfect temperature to make sure we can cut it efficiently without making it bad for our employees. Right now, it's a very slow rate.
Yeah.
The more amperage you add in, the faster it's going to cut. Along with the more pressure, or if you slide it, it's going to cut a little faster. You can see it actually speeds up.
Oh yeah, sure.
So that's stuff we're trying to think of how to implement.
Yeah. So like William back at the other one, he was pushing. So if you push through that wire, it'll just zippity zip.
Right. The more harder you push, the actually faster it will cut. Right now, it's at such a low temperature, and you can actually see it's not actually melting at how you would expect.
Very
but
cool.
you can also see the smoother. Of course, you would have the strings due to the low temperature, but the hotter it is, you won't have strings.
But the nice thing, there's no debris floating around or falling off.
No debris.
Nicholas, thank you.
Yeah,
Appreciate
thank you.
it. All right.